let's look at few more illustrations. What I have now is a medium of glass, as in I just have a glass and I have made a hollow region inside the glass, and obviously that hollow region won't contain anything, so that would be vacuum. Under that situation, that hollow region is kind of an equiconvex hollow region, and if I draw that, it would be something like this. Whole of it is your glass, but there is a equiconvex hollow surface, or hollow region rather, not surface, hollow region, and that hollow region is just vacuum. So glass is a refractive index of 1.5 or 3/2. Vacuum has a refractive index of how much? I'll just write mu of vacuum, V denotes vacuum, as 1. If you use your lens maker's formula, we'll gradually understand that this is a diverging lens. No matter this looks like a converging lens, but it is not, because as I have repeatedly said to you, that the geometry of the lens is not the sole decider of the converging or diverging property. It's the combination of two things, geometry and the relative refractive indices. Lens maker formula says that 1/f is equal to mu2 upon mu1, where mu2 is the refractive index of the medium, the lens medium, and mu1 is the outside medium, minus 1 upon 1/r1 minus 1/r2 with proper sign conventions. Now, in this situation, you will have a diverging lens of some focal length, right? And I have given you that the radii of this convex region is 10 centimeters. What I need to find out is with what material I should fill this vacuum or the hollow space, hollow region, so as I don't change the magnitude of power produced by this hollow region, only the sign is reversed, which means this is a diverging kind of a hollow region, so I'll have a negative focal length and negative power. So I need to invert the sign to a positive value. I have to make it converging but of the same magnitude, the focal length and the power of the same magnitude. So how do I achieve that? Let's calculate that. So what I need to find out is with what material, or rather the mu m of the material, refractive index of the material, I should fill so as this becomes a diverging hollow region of the same power, which means magnitude wise. Let's first calculate the power in the original circumstance. In the original circumstance, my power, or the 1/f value, would be simply equal to, inside I have mu v, which is 1, so let's write 1 by mu g, which is 3/2, minus 1 1/r1, 10 towards the right side, so positive 1/10, minus, this is towards the negative side, minus 10. These two signs becomes positive, so this is 2/10. This effectively becomes, this here is your 2/3 minus 1 into, this guy becomes 2/20. 2/10 rather, not 20, 2/10. So this becomes minus 1/3 into 2/10. This is a 1/f value. In the original situation, this would imply your 1/f as this guy over here is minus 2/30, so minus 1/15. So this implies a focal length of a minus 15 value and power of minus 1 by 15. Let's write that thing for you, or you might just get confused. In the new situation, I have to fill it with a medium so as f changes the sign but not the magnitude. So if I use the same lens maker's formula now, what I'll have is 1 by 15. Only the sign has changed and medium has changed. In place of air or vacuum, what I'm doing is I'm putting some medium, mu m. So mu m upon glass, because glass is the surrounding over here, 3 by 2 minus 1, and the same thing is copied down. This is not changed. I'll just write 2 by 10 over here. I'll not do the same calculation again and again. That is kind of disrespecting your intellect. I'll not do that. Now, if I carry the calculation further, what I'll get is 2 mu m upon 3 minus 1 gives you, this 2 by 10 goes here, becomes 10 by 2. 10 by 2 is 5. So 5 into 1 by 15, which is 1 by 3. So this thing here is 1 by 3. If we take this thing there, it will become how much? 4 by 3. So 2 mu m by 3 becomes 4 by 3. Further do the math, cancel out the 3, cancel out the 2, you will get mu m as 2. And this is the answer. If you fill the hollow region with a material having refractive index 2, then you will get the power to be of the same magnitude but of the opposite sign. I mean, I've produced a converging lens out of this from a diverging situation, which was the vacuum situation. Let's go on to the next case, next illustration. Now what I have is two immiscible liquids, and I have dipped a lens into that mixture, or rather into that solute, into that mixture of two immiscible liquids, and that looks like this. Now, I've drawn the boundary, but there is no such boundary as such. It's all over the region, all over the universe, two immiscible liquids. An hypothetical situation, just a construct to give you an idea. Now, the upper half of this is filled with a different liquid and the lower half with a different liquid. Both are of different refractive index, immiscible. This mu1 is 1.2 and this mu2 is equal to 2.5, and this is glass. So glass naturally has refractive index of 1.5. Now, if I keep an object at infinity, I will have different images formed because of both these two liquids. If I just consider the upper half, I will have a converging lens. Why? Because glass has a greater refractive index than the medium, and this is an equiconvex lens, right? And the radius of this particular lens is not been given to you, but there's a catch over here. There's a different kind of information given to you. If this lens was in vacuum, the focal length of lens would be equal to 20 centimeters. So if the lens was in vacuum, the focal length was 20 centimeters, but now it is not in vacuum, so it would have a different focal length. And focal is that length of a converging lens at which rays coming from infinity or the parallel rays meet. So this is where the rays would have met if there was no such immiscible liquid essentially, not say immiscible liquid region. But I have 1.2 here, 2.5 here. Because of 1.2, I'll have a converging lens perfectly fine. Towards the right side of the lens, I will form an image. But because of this 2.5, it is greater than 1.5. So I won't have a converging lens, I'll have a diverging lens. So my image in that situation would be not to the right but to the left hand side, right? And the question over here is to find out the separation between two images. If object is at infinity. This side over here. Now what I should do is I should apply my lens maker's formula and find out the focal length value for both the situations, because that would give me the position of image if the object is kept at infinity, and those focal length would give me the location of the image, and then I can subtract them to get you the separation between the two images. Let's do that then. So 1 by f1 for the upper part is equal to 1.5 by 1.2 minus 1 upon 1 by, I can say 1 by r minus 1 by r1 minus 1 by r2, but I have been provided some value about the lens. What? F in vacuum is 20 centimeters, which means that if I do a further analysis, I'll get 1 by 20 is equal to 1.5 minus 1 multiplied by 1 by r1 minus 1 by r2. Let's make a formula for vacuum. This 1.5 minus 1 is 0.5. 0.5 goes below, then I'll have 10. So this implies that 1 by r1 minus 1 by r2 for this lens over here is 1 by 10. Keep plugging in this value all throughout and you'll get the answer. This is 1 by 10. This is how much? This is equal to, this is 1.5 by 1.2. Decimal goes away, 15 by 2. This effectively becomes 5 by 4 minus 1. 5 by 4 minus 1 is 1 by 4. So this is 1 by 4 into 1 by 10 from here. This is your 1 by f1. This gives you f1 as, invert this, 40 centimeters. The next part, for the second part, again I'll use the lens maker's formula. 1 by f2 is equal to, mu2 here is 1.5, rather I'll not say mu2, what I'll say is refractive index of the medium, which is 1.5, medium of the lens, by refractive index of the surrounding, which is 2.5. This is 2.5 minus 1 into the same old guy, 1 by r1 minus 1 by r2, and that we have already found out as 1 by 10. Plug in that value. What you will get is 1 by f2 is equal to, this thing's 15 by 25 because decimal goes away. So this becomes 3 by 5 minus 1, which is minus 2 by 5, gives you minus 2 by 5. And this effectively is your 1 by 10 just from here. If you invert it through, you'll get f2 as 50 upon 2, the negative sign. So this implies that f2 is equal to 50 upon to the negative sign, so minus 25 centimeters. Without even subtracting these values, you would understand that F2 is 25 here and F1 is 40 here. So 40 here, 25 here. What is separation? It's 65 centimeters. I could have even subtracted them. 40 minus 25 gives you 65. Separation would be how much? It would be equal to 40 centimeters plus 25 centimeters, which is 65 centimeters. This is your answer. I mean, what I have done is I have calculated the focal length for both the situations, for the upper half and the lower half. That would be the image formation if rays are coming from infinity, if the object is at infinity, and one of them gives you object at right hand side, the other the left hand side. So naturally separation is just adding them up magnitude wise, 40 with 25, or rather the mathematical term subtract them. 40 minus of minus 25 becomes plus 25, so 65 centimeters. 65 centimeters is your final answer. That is separation between the two images. Now let's move to a third situation, the 11th situation. The 11th situation is a bit different. In this situation, I'm trying to introduce motion. Till now, we have been dealing with objects at rest. We haven't been dealing with objects in motion. But right now, let's try to introduce motion to the object and then think about what happens to my reflection, right? How the image position changes. So let's say you have a concave mirror over here of 10 centimeters focal length. When I say concave, naturally it should be negative 10 centimeters, and I have kept the object 30 centimeters away from me. Not me actually, from the pole of the concave mirror. This is a mirror, so just shade it through or else you'll get confused. Silver it through. This object is not at rest. This object over here is moving with some velocity. And that velocity vector is 4i cap plus 6j cap. What would be the velocity of the image? The question is, find the velocity of the image at this point itself, not as a function of time, at this point itself. If you look at this question, this looks kind of very vague and a weird question, and you feel that this is not solvable. I mean, we haven't been taught to solve such questions. But if you look it through, you understand that this essentially is the same old question with a bit of packaging different here and there. What's happening over here? I can use my lens mirror formula. 1 by V plus 1 by U is equal to 1 by F. What is V over here? V is the image position. Let's use image position as some x, right? This thing over here, some x. And what exactly is happening to the object? It is coming towards the mirror with 4 meter per second. Just write centimeter per second rather, not meter per second. Centimeter per second. 4 centimeter per second towards the pole. So distance between the pole and the object is decreasing at 4 rate. So I'll have to use that thing. Initial 30, but it's decreasing at the rate of 4 per second. So 4 into time. But with a negative sign too, because it's to the left of the pole, right? Equal to 1 by F, which is 1 by minus 10. Now this is giving you x as a function of time, right? If you simplify, you'll get x as a function of time, which is the position of the image as a function of time. And if I differentiate it once, I'll get dx upon dt, or the horizontal velocity of the image, right? Let's try to calculate that. If you differentiate it, you'll get minus 1 by x square. I'm using chain rule over here. I hope you are familiar with chain rule by now. I don't need to give you chain rule explanation again and again. This plus minus becomes minus, and this comes the 30 minus 40 square. Differentiate the inside, which is minus 4. This is equal to 0. What is dx upon dt? This is the velocity of the image x direction, right? So you have got dx upon dt as, just take this thing to that side. You'll get this minus minus plus towards that side, the minus gets cancelled from this. So dx upon dt is x square 4x square upon 30 minus 40 square. At this instant, t is equal to 0, right? If t is equal to 0, I can very simply do it. T is equal to 0, this thing goes away, this 40, I have 30 square. And here I have x square. What is x at t equal to 0? I need to find that out, right? I'll use this equation. This essentially is a mirror formula, so let's try to use that. I'll use it here. Now at t equal to 0, I have 1 by x plus 1 by minus 30 is equal to 1 by minus 10, because initially 30 centimeters away from the pole. This gives you 1 by x as, this guy goes over there, I have 1 by 30 minus 1 by 10. This gives you 1 by x as, this is 30, 1 minus 3. So this gives you x as inverted through. You'll get 30 minus 2. So this means x is equal to how much? Minus 15. Plug in here x square. You'll get the value here as 4 times 15 square upon this thing, which is 30 square. What do you get here? 15 square upon 30 square. This essentially is half square of 4. So dx upon dt gives you 1. So dx upon dt is your 1, right? I can also write 1 centimeter per second. What about the y direction velocity? I know magnification at this location. Magnification would be equal to minus of v by u. What is v here? Minus 15. What is u? Minus 30, right? So if you use this thing here, you'll get magnification of minus half. What exactly is magnification? Magnification means height of image by height of object. Over here, I can perceive this as dy upon dt, the velocity of the image, because that's the motion is substituting my vertical dimension. Now HO, what is HO here? Is the height of the object, which is going up by 6. So I'll just write a plus 6 term over here. And this guy is minus half. This is magnification essentially. Just write a minus half. If you simplify it further, you'll get dy upon dt as 6 goes over here, This becomes minus 3 centimeter per second. So here you have dy upon dt and dx upon dt. Remember these values. Why you're needing them? You need them because these two are the components of velocity of the image in x direction, in the y direction. Positive means towards the right, negative means towards below. So if my question was that find the velocity of the image, what I will do is dx upon dt I cap plus dy upon dt j cap. So what I'll write over here answer is this I cap 1 into I cap and this into j cap, which is minus 3j with a proper dimension. So this essentially is your answer. I cap minus 3j cap centimeter per second is the velocity of the image. So here we have dealt with a very complex situation which looks complex only. It's not complex essentially. And we have figured out how to do it. First we'll do the mirror formula and find out the velocity of the image in x direction, and then we'll apply the magnification thing to find out the motion in the y direction of the image, and then we'll club them together with I cap and j cap terms. Now let's look at the last and the most interesting of the illustrations of this chapter. What we have over here is a system of two concave mirrors mounted like this. The mass of this system is m. The dash is for denoting that these are the reflecting surface, so they have to be silvered or polished. It is mounted like this, and the whole setup, these two concave mirrors and this frame on which it is set is of mass m. Let us say capital mass m. The radii, magnitude of the radius of curvature for both these concave mirrors is equal to r. Now what I have done is this is resting on a surface, frictionless surface all throughout, and I have two objects of capital mass m. This diagram may look a bit absurd, but you have to understand that even though this looks a big block kind of a thing, you have to imagine that the rays would be paraxial, aperture would be small, so all my mirror formula assumptions are valid. So I can apply mirror formula. Just bear with that idea. And this mass, this mass, this mass, all have the same mass. Surface is frictionless. The distance, initial separation between the mirror arrangement and this mass is 2r. The same goes for this side also. This is a perfectly symmetrical scenario. But there's only slight difference. The difference is that I have given this mass at some velocity towards the left. Let that be v. So when this mass would gradually come towards this mass, it would collide with this mass, this arrangement, and that collision is given to as elastic. Now after the collision, even this would move, this would make collision with this, that will also be elastic. So you're being asked that find out the location of the image with respect to this position, I mean initial position of this arrangement. Put this equal to x equal to 0 and this line AB as your x-axis. So where would the image be formed of both these masses at 3 times? What time intervals they are? I mean what instance of time they are? The first is r by v. The second one is Ry V. The third one is five R by V. All my collisions are elastic, perfectly smooth. And if you remember something about collisions, you'll understand that for elastic collisions of two equal masses, after the collision, the velocities are exchanged, which means after collision, this would come to rest, this would start moving with v velocity. Now, after this collision, the mirror would stop here and this mass would start moving here. Do you get the idea? I can divide this motion into three categories. From 0 to 2r by v. From 0 to 2r by v, what will happen is this would go on like this. That would be at rest, this would be at rest. After 2r by v to 4r by v, what will happen is this would be at rest, the mirror would be moving towards this till 4r by v. After 4r by v, the mirror would hit this mass, collide with this mass, mirror would come over here, this mass would be over here, and this mass would be proceeding towards this direction. So I can successfully divide this motion into three distinct categories. Now, where does this r by v fall into? This r by v is in the category of x between 0 to 2r by v, which means that these two would be at rest and this would be moving towards the mirror, and at r by v, what I can make a smaller diagram for this. I have a point over here, I have two mirrors over here. See, I'm drawing a smaller diagram for your illustration, for your better perception. This thing is your 2r. And after r by v, this would have moved by some r distance, because r by v is the time. And time into v would give you the distance. So v into r by v is r. So this thing would be r. Now I know that if my object is r away from the mirror, image would be formed in the object itself, right? But in this case, it is not r away, it's 2r away. So I'll have to use mirror formula for this situation. From this position, right? Let's use that. 1 by minus 2r plus 1 by v. This v is different from that v, right? So I'll kind of use a different notation. I'll use v naught for this. This denotes the image distance. This is equal to 1 by r by 2, the focal length, or just 2 by r I can write over here. And this would be of a negative sign. Why? Because this is facing to the left side. Negative sign. So your 1 by v naught comes out to be 1 by 2r minus 2 by r. This is equal to 2r 1 minus 4. Invert it through. You'll get v naught as minus 2r by 3, which means the position of the image of this one, when it would be here, right? It would be on the object itself, and this one would be here, minus 2r by 3. So I can write the coordinates as image of this would be at minus 2r by 3 with respect to this point. This is my x equal to 0, because my mirror has still not started moving. This is r to the right side. Why r? Because object and mirror are, object and image are forming on the same point, because r is the radius of curvature, and whenever you keep the object at the radius of curvature of a concave mirror, the image would be formed on the object itself. So this is solution for the first part. Now let's move to the next part, 3r by v. Where does this belong? For 3r by v, this is t between 2r by v and 4r by v. What is the meaning of this gap? 2r by v means it has collided. 4r by v means now this has collided with this. So I'm between here, which means if I can draw the diagram for this, let's draw the dot diagram for this situation. What's happening is collision has been taken place and now this has proceeded ahead by r. So this is your x equal to 0, where my mass is this mass, and this is the position of the mirror arrangement, which would be essentially r from here. This is x equal to 0, right? And this is the position of your this object, which is at 2r away from origin and r from this position, right? In this situation, if it is r away from the mirror, the image would be from the r itself, which means here itself. But from the origin, it is r plus r away in the negative direction. So minus 2r, right? What about the other one, other image? Now this guy over here is also r away from the mirror. So image would be from the object itself. But here it would be on the origin, right? The object would be on this point, which is origin. So if I have to write the answer for this, what I will get is the coordinates would be simply minus 2r, comma 0. Minus 2r corresponding to this length and 0 corresponding to this object. I have two objects and images are formed on those respective objects. Why? Because they both are r away from the respective mirrors. So they would be formed on that point itself. So this is the answer for the second part, the location of the images, point images. What about the third part? Where does this belong? Third part belongs in the category of time greater than 4r by v. What do you mean by time greater than 4r by v? Time greater than 4r by v means this has collided with the mirror starts proceeding, collides with this mass. So this mass is now here, the mirror is here, and this mass has further proceeded here. So if I can draw, what will happen is, this is your x equal to 0. Here I have my this object. Then as this has moved here, the mirror has moved here 2r ahead. So here it is a mirror position, right? This is at how much distance away? 2r from x equal to, this is x equal to 0 position. Now r further, because 4r by v to 5r by v is your r by v, so r by v into v is r. So this is your location of this object. If this is r away from the mirror, the image would be formed on r itself, right? But what will happen to the other case? This is 2r away, right? So I'll have to use the lens mirror formula again. If I use the mirror formula again, it's similar to this idea, right? I'll get minus 2r by 3. But that minus 2r by 3 would be with respect to which point? With respect to this point. So one image would be here of this point and the other image would be here, right? This would be your image. This would be how much? 2r by 3. I need this length. So this length, let it be some unknown z, not z, I'll write it some h, right? So h plus 2r by 3 is equal to 2r. So h turns out to be 2r 1 minus 1 by 3. So h is equal to 4r by 3. Now this h measurement is in the negative direction. So this guy is minus 4r by 3. for sign convention thing in terms of x coordinate. And this is 2r plus r, the image of the point, this point which has moved further away. So my answer for this would be minus 3r comma minus 4r upon 3. See, what I've done is I've just used the concept of collision and tried to use some intuitive arguing here, and the arguments are very simple to follow. I don't need to explain it again to you, but you can rewind this video, play it again to find out where do you miss out here. And I don't think this is too difficult. This is self-explanatory.